Electronics play a vital role in supporting our daily lives. Devices such as smartphones, computers, and automobiles have become indispensable parts of modern life. Most of these products rely heavily on semiconductors and electronic components, enabling a high level of digital control. Electronic devices composed of numerous electronic components are now interconnected globally. Plating technology is essential for maintaining the performance of these components. Japan Pure Chemical Company, JPC, specializes in developing plating chemicals required for the contacts and joints of electronic devices that support our lives. As a leading manufacturer of noble metal plating chemicals, JPC has significantly contributed to improving the performance and reliability of electronics. In smartphones, computers, and other electronic devices, numerous components are mounted on the substrate to achieve superior performance and efficiency. As electronics continue to evolve, the contact areas within circuits have become smaller and smaller, requiring increasingly precise plating techniques. The smaller the electronic components, the more likely electrical noise and energy loss will occur. Therefore, higher precision plating processes and improved durability are required to prevent interference. As a small, elite, fabless, development-oriented company, JPC creates added value by leveraging proprietary technology to formulate chemicals, specializing in recipe development. For over half a century, JPC has been a leader in the plating industry through continuous technological innovation. Additionally, with the rise of electric vehicles, JPC has developed advanced plating technology to support new materials, including high-voltage and compound semiconductors, to meet the needs of the modern era. We have developed products tailored to AI and power semiconductors, emphasizing characteristics such as high efficiency, fast processing, high voltage, and high current. This video will introduce some of Japan Pure Chemical's advanced support technologies for electronics. The protecting agent PA is a key component of JPC's plating chemicals which prevents oxidation and corrosion of the underlayer metals, while enabling uniform gold plating deposition formation. This PA component selectively adsorbs to specific underlying metals, controlling plating reactions and plating deposition properties. Let's take a look at how it works for electroless nickel immersion gold ENIG plating. ENIG is one of the standard surface treatment processes for solder mounting components on printed circuit boards. The gold plating deposition protects the nickel surface from oxidation until the solder surface mount process is complete. When heated, the gold diffuses into the solder. The solder then forms a robust alloy layer with the fresh, non-oxidized nickel, which was protected by the gold. During the ENIG process, immersion gold plating is performed after electroless nickel plating. When the nickel film is immersed in the gold plating solution, a nickel-gold substitution reaction is triggered, depositing a gold film. With conventional immersion gold plating, immersed nickel-plated material oxidizes on the surface due to oxygen in the liquid. Additionally, localized nickel corrosion can occur, resulting in non-uniform plating. These issues can result in mounting defects. Incorporating JPC's PA can solve these problems. When the nickel deposition is immersed in a gold plating bath with PA included, PA adsorbs on the nickel surface, and prevents the nickel deposition from being oxidized by dissolved oxygen. The PA adsorbs on the nickel surface and is repeatedly desorbed and adsorbed. An orderly substitution reaction of gold and nickel proceeds when PA desorbs. PA protects the nickel surface and allows substitution to proceed, resulting in a uniform gold-plated film forming. Using JPC's plating solutions containing JPC's PA ensures the highest level of solder joint reliability. It can also be combined with other underlayer metals and materials by changing the PA type. As a result, we have successfully developed outstanding plating solutions by applying PA technology. Aerobrite Bar 7 is designed for fine area partial plating on connectors, allowing precise control of the plating range by adjusting chemical concentrations. As connectors become increasingly miniaturized, partial gold plating requires greater precision. With conventional gold plating, solder spreads to the contact areas of connector pins during connection to the board, causing contact failure. JPC's nickel barrier technology addresses this issue. By performing partial gold plating only on the contact parts and the solder mounts, the wetting spread of solder stops at the nickel and does not spread to the contact area. Let's take a closer look. To form a nickel barrier, plating, applying a plating solution via spraying, is performed. For precise plating, it is essential to use not only the appropriate plating methods but also a plating solution that ensures high area accuracy. This process involves partial plating on the base nickel. Partial gold plating is applied using a spray plating solution from a nozzle. When conventional plating formulations are used, gold plating tends to spread over a wide area of the connector pins, but using Bar 7 can significantly reduce this spread. Bar 7 allows for narrow-width gold plating, enabling the formation of a highly precise nickel barrier. Bar 7 also eliminates gold plating on unnecessary areas, reducing plating costs. In recognition of its effectiveness, Aerobrite Bar 7 is widely used for miniaturized electronics such as smartphone connector pins and sockets. Next, let's talk about the next generation of nickel-free plating. With the introduction of the chiplet package and other enhancements, semiconductor package substrates have become finer and more advanced. The currently used surface finish for package substrates is electroless nickel, palladium, gold plating ENEPIG, which have high solder joint reliability. Electroless nickel plating is first applied on copper, with a thickness of 5 micrometers usually required. At this stage, a film is also formed on the sides. When the space between patterns is large, this is not an issue. However, as the patterns become finer, they can bond to neighboring patterns, causing a short circuit. To address this issue, we have developed the EPIG process for direct palladium gold plating on copper without nickel. The palladium gold plating film is significantly thinner than when a nickel layer is included. This prevents short circuits even with fine patterns. However, achieving good adhesion with a palladium plating film on copper is challenging. The problem is the generation of voids at the interface between the copper and palladium film. We resolved this issue by applying our PA technology. The result is the EPIG process. We have confirmed that a palladium gold film can be formed on copper without deposition outside the wiring, even with very fine wiring. In addition, high-frequency support is essential for 5G and future generations of mobile communication systems. The nickel-free plating process achieves this and is highly effective for high-frequency performance. We expect it to see wider adoption in the future.
メッキっていうのは、一般的にはメガネ、時計、指輪の装飾の金メッキっていうのが思い浮かばれると思うんですが、当社の金メッキっていうのは接続接点、特に電子材料に多く使われています。例えばスマートフォン、パソコン、車、サーバーの部品と基板をつなぐ接続接点、ここに当社の金メッキが多く使われているんですが、架け橋となる、まさしく接点材料を我々は作っている。やはり小資源、ここはもともとの私たちのメッキ事業、メッキ薬品事業、これがもうそもそもがサステナブルになっています。ただそのサステナブルをもう少しエネルギーで読み替えると、電池材料、ここに役に立てられる技術です。電池っていうこととメッキっていうことは全く別物のような捉え方をしていると思うんですが、メッキっていうことと充電っていうことは全く同じプロセスです。これらも全てプラス極とマイナス極の電極が用いられています。そこの電極、電解質、電解液、ここの分野にこれまでの酸化還元の技術、これを活用して急速充電、急速放電、ここの技術の材料に我々の技術は貢献できるのかなというふうに今期待しているところです。当社の理念っていうのは科学の好奇心でエレクトロニクスに役立つ。その会社でケミカル、エレクトロニクス、この架け橋となる。これが我々の経営の理念、ここにつながっているものだと思っています。